Hello and welcome to Mr. Hamilton's Math Bites. Today we're talking about multiplying and dividing rational expressions. If you've already gotten comfortable with factoring and with canceling out terms that are the same in the numerator and denominator, this is going to be a really easy thing for you to do. The only thing you'll have to watch is that you're very careful with your mathematics. It's easy to make mistakes. Let's start by looking at a couple of examples when we're dealing with multiplying rational expressions. Now the steps we're going to take is we want to factor the numerators and denominators, we want to divide out the factors common to both, multiply the numerators together, multiply the denominators together, and write it as a single expression, and then we want to list the restrictions from the steps prior to canceling any terms. I suppose I should have a bracket to finish that off. So here's the first example. What we're going to say here is simplify, and generally speaking you're going to have list restrictions on the variables, or state restrictions. So the example is x plus 2 over 3x plus 5 times 3x plus 5 over 5. And some of you right away are going, well, that's obvious. I can cancel the 3x plus 5 and the 3x plus 5, and that's all that's left. And you're absolutely correct. And in fact, you could go ahead and you could actually write this line as shown. Really, that's the same thing. And then we can clearly see that 3x plus 5 cancels out. So you're left with x plus 2 over 5. And the restriction here is that 3x plus 5 cannot be 0. 3x cannot be negative 5, and that means that x cannot be negative 5 over 3. So there you go. That's our first example. Let's look at a second example that has a bit more factoring involved. X squared minus 4x minus 5 divided by x plus 4 times x plus 4 divided by 2 times x minus 5. Now, one of the questions I often get is, if there's no brackets around, does that mean it's multiplied? Well, absolutely. Because it's written as it is, it's as though there were brackets here, here, and here. But because if we write it as a rational expression where we have a line below, it's assumed that those values are as though they were in brackets. But we don't have to write those brackets. The only thing that I really need to factor here is this. And I hope you're getting fairly comfortable with especially simple trinomials. Adds to negative 4, multiplies to negative 5. Well, those two numbers have to be negative 5 and 1. So what we get here is x plus 1 times x minus 5 times x plus 4, and this is over x plus 4, and this is over 2 times x minus 5. And so I would actually suggest that let's get rid of the multiplication sign altogether. It makes it really easy to see it cancel out if you're at all confused with it. If you get it, you don't have to do this last step, but if you're at all missing the point, this is always a good step to help you. So you see that the x plus 4 cancels out, the x minus 5 cancels out, and what we're left with is x plus 1 over 2, where we have the restriction that x plus 4 cannot be 0, and x minus 5 cannot be 0. That means that x cannot be negative 4, and that x cannot be positive 5. Now let's look at some dividing examples. And I want to start off with something that is actually not even really a rational function, it's just some numbers. When I divide 4 over 3 by negative 2 over 15, what do? Well, I hope you remember from grade 5 that all you do is you invert and multiply. And this becomes 15 over negative 2, or I could write that as negative 15 over 2. It doesn't matter where the negative is. And then you'd multiply these together, and you multiply these together. However, there's also something we can do to make things a little simpler for us, and that is we could go ahead and we could cancel out the common factor, much like we're doing here with the rational expressions. And the common factor here would be 5, or the common factor would be 3, which would cause the numerator over there to be 5, and the denominator to be 1. Common factor here would be 2, become negative 1, so what we'd be left with is 2 over 1 times 5 over negative 1, and you just have negative 10. And so with the same thing we're going to apply now to a rational function. The only really new step here is this invert and multiply step. So here's the second example. X squared minus 1 over x minus 2 divided by x plus 1 over 12 minus 6x. X squared minus 1 is a difference of squares. So that becomes x minus 1 times x plus 1. But I'm getting ahead of myself. I want to invert and multiply. I like to kind of factor as I go. I want to make sure I change that to multiplication and invert this. This is 12 minus 6x, moves from the denominator to the numerator, and the numerator, x plus 1, moves to the denominator. So now I have a common factor of x plus 1 here and here, and I'll list the restrictions in a minute, because there's something I want to point out with that. The other thing I can notice here is that I can actually factor this 12 minus 6x in the numerator. This becomes x minus 1 over x minus 2 times 12 minus 6x. It's not over 0, it's over 1. There's still a factor of 1 there. But now I can factor that as I noted. And so I can take a common factor out of there of 6. And when I take out that common factor of 6, what you get is 2 minus x. Well, 2 minus x and x minus 2 are very close. So now I'm going to not only factor out the 6, but I'm going to factor out a negative 6. It's going to become x minus 1 over x minus 2 times negative 6, and that's going to switch the signs of both of these. So that becomes x, positive x from a negative x, and now the 2 becomes negative. And I'm just writing the order reversed like we did when we factored earlier in the unit, so that I can clearly see that that and that cancel. And what I'm left with here is I'm left with negative 6 times x minus 1, or x minus 1 times negative 6. It's just easier to write the whole number out front. And that's it. But the restrictions are what? Well, there are several restrictions here actually. There are more than we've seen before. There's a restriction here on the x plus 1. There's a restriction here on the x minus 2. But I hope you caught the third restriction. The third restriction is here. Because initially this 12 minus 6x was in the denominator. So we have a whole bunch of restrictions. We have a restriction that x minus 2 cannot be 0. We have a restriction that x plus 1 cannot be 0. And we have a restriction that x, or rather 12 minus 6x, cannot be 0. So that means that x cannot be 2, x cannot be negative 1, and rearranging this we get 12 equals 6x, dividing by 6 gets x cannot be 2. And in fact, that's the same restriction as I had previously, simply because those two factors ended up canceling out. So really we don't need to have this restriction because it's already been written down. Alright. So have fun simplifying rational expressions by multiplying and dividing.